processes in the petroleum industry operate at high pressure. Normal working pressure helps keep production vessels operating efficiently. But excessive pressure can be dangerous to both people and equipment. And for this reason, vessels are equipped with pressure relief devices to guard against excessive operating pressure. This is the first section of a four-section module covering the importance of relief and safety devices commonly used in the petroleum industry. In this first section, we will see how excessive pressure can present a safety hazard and how excessive pressure can be relieved by special devices. Millions of years ago, high pressure and temperature helped create petroleum. And today, high pressure and temperature are still very much a part of the production process. Production separators and heat treaters, for example, use pressure and heat to remove oil and water emulsions and natural gas from other well fluids. During these processes, excess liquid and gas pressures can build up in process vessels, as well as in pipelines and storage facilities. If this overpressure is not relieved, serious damage can occur to the vessels and pipes. And when vessels or pipes burst from excess pressure, there can be potential safety hazards to personnel, equipment, and the environment. There are many different kinds of pipes and vessels operating under different conditions and in different environments. But all pressure relief devices fall into three basic types: relief valves, safety valves, and rupture discs. Let's look at the basics of these three devices. In liquid systems, the action of quick closing valves throughout the system can cause hydraulic pressure waves. These pulsating waves are commonly called water hammer and can damage vessels and piping. This excess liquid pressure can build up quickly and must be relieved quickly. Relief valves are commonly found in liquid processing systems and in areas where system pressure can build up during processing. As you can see, relief valves come in a variety of designs and can be found in many different vessels at any stage in processing. Another relief device is a safety valve. Safety valves are used in both liquid and gas systems, where pressure builds up rapidly and must be relieved quickly. For example, in a liquid system, this can happen when a pump discharge line is blocked shut. In gas and steam systems, pressure can build quickly because of change in processing conditions. In gas and steam systems, overpressure may be caused by changing pressures coming from the well, or by high heat buildup somewhere in the system. The vessels and pipes that are used for gas and steam processing are built to handle the normal operating pressures, plus a margin for safety. Here again, high pressures can build up very quickly and must be relieved quickly. This valve is sometimes called a pressure safety valve or pop valve. It quickly opens all the way to relieve the high pressure condition, then quickly closes all the way when pressure is back to normal. Sometimes pressure can build up higher or faster than can be relieved by the devices we've mentioned so far. The third type of device, the rupture disc, can be used by itself or in addition to a relief valve or safety valve. Rupture discs are typically set at 25% over the setting of the relief valve or safety valve. When the system pressure reaches the rating of the disc will burst open to provide dependable and infinite pressure relief. Whether installed by itself or along with a relief valve or safety valve, the rupture disc can be found on a variety of vessels, and each one may look slightly different. High pressure and high temperatures are an integral part of petroleum production, and we must take precautions to keep them from getting out of control. In this section, we've looked at the basics of pressure relief devices. We've gone over how pressures and temperatures can build up, and the three basic types of devices that help relieve the excessive pressure from pipes and vessels. All right, take some time now to stop the videotape. Fill in the blanks and answer the questions in the student manual. you come back, we'll go over some of the specifics of how these devices work. See you when you finish. When pressure builds up in a liquid processing system, it can occur gradually or it can occur quickly. A relief valve is designed to automatically open in proportion the increased pressure. This is the second section of a module covering safety relief valves and rupture discs. Section 2 covers the design and operation of direct acting relief valves. Relief valve commonly found in liquid processing systems. When pressure increases above the normal level, the relief valve opens to bleed off some of the liquid into a vent bypass line. If system pressure continues to build, more liquid must flow out of the system. When pressure falls back to a normal level, the valve closes. Typically, relief valves are set to open at the maximum allowable working pressure. Most older systems use a direct acting type of valve. Now on newer installations, it is more common to see a pilot operated relief valve. Alright, there are two types of direct acting relief valves, spring loaded and weight loaded. Let's take a closer look at how they are designed. In a spring loaded relief valve, components are the casing, the inlet, outlet, disc, seat, the spindle, sometimes called the stem, and the cap. The disc or plug is kept in place by a spring washer, adjusting screw, and a lock nut. The entire assembly is enclosed in a casing that is threaded or flanged at the outlet and inlet for connection to the system. Besides providing a method for connecting to the system, the casing also forms a protective enclosure for the parts and hold them in place. The disc of the relief valve is held against the seat by the spring assembly. This blocks the path between the inlet and the outlet until the system pressure increases above the pressure setting of the valve. Some relief valves use a seat that's a permanent part of the valve. Others have a threaded seat bushing. The spindle guides the up and down motion of the disc. The spring goes around the spindle and held in place by the disc or spring washer at the bottom and a spring washer at the top. The adjusting screw exerts downward force on the spring washer and the spring. The adjusting screw is also used to compensate for changes in the spring tension over time. A nut keeps the adjustment secure. A cap covers the top of the spring assembly to keep dirt out. The cap also reduces the chance of tampering with the valve setting. Relief valves are made to function over a range of settings. There's an ID tag on the valve that lists the operating range and set point. And on the vessel, the ID plate indicates what the specific operating pressure should be. As the pressure reaches the valve set point, the valve begins to open. Let's take an example. Say the set point is 20 psi. When the pressure in the system reaches 20 psi, the disc lifts off the seat and the valve opens. The greater the system pressure over the set point, the more the valve opens, until it's fully open. The vertical distance the valve opens is called the lift. It is common for relief valves to have lifts from a fraction of an inch to several inches. As the system pressure reduces to the set point, 20 psi is our example, the downward force on the disc starts to close the valve. The valve will completely close at a pressure 5 to 7% below the set point. Spring-loaded valves are used in high-pressure applications because the springs can develop strong holding forces. As the disc is lifted, the compression of the spring makes it more difficult to lift the disc. In the weight-loaded relief valve, the seat closing force is provided by the weight pallet and lever assembly. Weight-load valves are usually used for operating pressures below 15 psi, such as in heater treaters and atmospheric vessels. Now, let's take a look at the installation of relief valves. Care must be taken when placing and adjusting relief valves. Only certified personnel should perform the work. Like many other safety devices, the function of relief valves benefits in three areas: protection of the personnel working in the area, protection for the operating equipment, and protection for the area around the equipment. Valves should be piped so that discharge flows to overflow tanks or into a vent line. Under no circumstances should discharges be allowed to spill onto the ground or splash into the equipment or personnel working nearby. For the initial installation, the relief valve is normally specified by the equipment manufacturer or by company engineers. In any case, use only the relief valve specified. When it's replaced time, check specifications with your supervisor. Then verify that you have the correct relief valve. If it's not exactly the same model or manufacturer, it must be exactly the same type, with the same operating range and set point. If you are replacing relief valves, remember you are working around high-pressure systems. Follow all the recommended safety practices and procedures, and read the directions carefully in the installation manuals and on the equipment itself. Get into the routine of checking each installation to ensure there are no leaks at either the inlet or the outlet. Check the valve itself. Make sure it doesn't leak. And there should be a proper discharge path for the vented liquid. Relief valves should not be shut in on the downstream side, except when the valve is being replaced. And that brings us to a stopping point. In this section, we've talked about the workings of a direct acting relief valve. We've gone over the workings of a spring-loaded valve and identified weight-loaded valves. And we've seen how relief valves are designed to protect personnel, equipment, and the environment. Now stop the videotape and look over this section in your student manual and answer the questions. When you return, I'll be over at another vessel and we'll talk about another kind of valve. See you when you get back. When pressure builds up in a gas processing system, it generally builds up rapidly and must be relieved rapidly. Relieving pressure in a gas system is accomplished with a different kind of valve, a safety valve. This is the third section of safety relief valves and rupture discs. In this section, we will cover the operation and various designs of safety valves. Gases and steam can be compressed. In fact, it is normal that when gas reaches the disc in a valve, it compresses, builds up before escaping through the valve. This compression can cause system pressure to build up rapidly. A liquid-type relief valve doesn't open fast enough to relieve gas or steam pressure. In fact, its slower action can contribute to the pressure buildup. So a gas system requires a valve that will pop wide open under excess pressure. That's the principle behind a pressure safety valve, or PSV. Even though a safety valve relieves pressure more quickly than a relief valve, their design and components are very similar. The direct acting safety valve is made up of a casing, inlet, outlet, disc, seat, spindle, cap, and on some, a lifting lever. The safety valve assembly is protected by casing, which is threaded or flanged for connection to the system. A cap covers the top of the assembly and reduces the chance of tampering with the valve setting. The disc is held in place until the system pressure increases to the point when the disc pops off the seat. The spindle guides the up and down motion of the disc. The adjusting screw is used to adjust the valve set point. If the spring tension changes over a period of time, certified personnel will reset the adjusting screw. The popping open of the safety valve is due to the design of the disc. There is a main surface of the disc which is always in contact with system pressure, and a lip which is not exposed to system pressure. At the set point, the disc will lift off the seat. But what makes this valve different is that the lip then becomes exposed to the system pressure, creating a larger surface for the system pressure to press against. This large area makes for a larger lifting force and causes the valve to pop open. When the pressure drops to a safe level, the same operation happens in reverse. And because of the high velocity of the escaping gas, the valve must close quickly and completely. Otherwise, the high velocity can damage the surfaces of the valve opening. Damage is also prevented by a key feature of safety valve operation known as the huddling chamber. This chamber provides a small cushion that keeps the disc from slamming into the seat and damaging the valve. The pressure at which a valve opens all the way is called the popping pressure. The opposite, rapid closure of the valve, is called positive seating. The difference between the popping pressure and the positive seating called blowdown. As an example, if popping pressure is 200 psi and the positive seating pressure is 190 psi, the blowdown is 10 psi. Some safety valves have another special assembly found in relief valves, the hand-operated lifting assembly. It's used periodically testing the valve. It does not move in the normal operation of the valve. But for testing, when the hand lever is lifted, the assembly pushes upward on the release nut. This action lifts the spindle and the disc. When the lever is released, the valve closes. Some valves are designed to be used as a relief valve in a liquid system or as a safety valve in a gas system. These are called safety relief valves, and they are commonly found in systems that contain liquid-gas mixtures, such as in production separators and heater treaters. It's common for a safety relief valve to have a nozzle-shaped inlet and two sets of adjusting rings. Depending on how the adjusting rings are set, the flow of the system pressure will either be directed at the lower rings for a relief valve or directly at the disc for a safety valve. These kinds of valves are adjusted at the factory for their particular type of service, and they should never be readjusted on site except by certified personnel. Often in a processing plant or an offshore facility, we use what's called a pilot-operated relief valve. Sometimes it's called a pneumatic relief valve. They have a sensing device for detecting system pressure that's separate from the pressure-relieving part of the valve. The components of a pilot-operated relief valve are the casing, inlet, outlet, piston, pilot line, disc, seat, and spring. System pressure is applied directly to the bottom of the piston and through the pilot to the top of the piston. When the pressure reaches the set point, the pilot opens. This blocks the pressure passageway that feeds the top of the main valve and bleeds off pressure from above the valve piston. This allows the piston to open and the overpressure is relieved. Sometimes when more than one pilot-operated relief valve is vented through a common header, a backflow could occur to downstream pressure. If backflow is possible, use a backflow preventer in the pilot line, check valve, or a split piston relief valve. Pilot-operated relief valves have many advantages over direct-acting valves. They're cheaper, they handle more volume, they provide a bubble-tight seal, and they're easy to test in place. As with relief valves, there are three important things to think about when installing and replacing safety valves. Protection for the personnel working in the area, protection for the operating equipment, and protection for the area around the equipment. The initial installation of each safety valve is normally specified by the equipment manufacturer or by company engineers. Only the valve specified for each application should be used. Safety valves and safety relief valves are designed to operate over a range of pressures. If you install or replace a safety valve, be sure to check the equipment ID plate and verify with your supervisor the correct type of valve required. Then check the ID tag on the valve to be sure it's the correct one. If it's not exactly the same model and manufacturer, it must be exactly the same type, with the same operating range and set point. As mentioned with relief valves, adjustments on safety valves should never be made except by certified personnel. Care must be taken when installing a valve that gas discharges are directed away from equipment and personnel. If necessary, the outlet should be piped into a vent line. And again, remember, you are working around high-pressure systems, so careful. If you install a safety valve, follow all recommended safety practices and procedures. Check the installation periodically. Be sure that there are no leaks in the outlet, the inlet, or the valve itself. And that brings us to the end of this section. We've taken a look at the various kinds of safety valves, how they're used, and how they're different from each other. We've also looked at safety relief valve, where it is commonly used. All right, it's time to look over your student manual and answer the questions. Take your time, and I'll meet you back here when you're finished. All of the pressure relief devices that we've talked about so far are specialized valves, each suited to a particular need. A rupture disc is a device that can be used by itself or in addition to a relief valve or safety valve. A rupture disc is the simplest pressure relief device. There are no moving parts. It's lightweight, fast-acting, easy to install, and relatively inexpensive. It may look like much, but oftentimes this little piece of dome-shaped metal is the last line of protection against overpressure. This is the fourth section, covering relief valves, rupture discs. In this final section, we will see how rupture discs are used to protect systems from overpressure. A rupture disc is designed to rupture at a predetermined pressure. Sometimes a support, or knife edge, is used along with the disc itself. The most common type of rupture disc, called a tension-loaded disc, is simply a holder with a pressure dome in the center. When the system pressure rises to a predetermined point, the dome bursts. Rupture discs are designed to fit into a holder that can be bolted in place between two flanges. An ID tag lists the size of the disc, type of material, and the rupture pressure in PSIG. The disc is placed in a fitting known as a safety head. Newer safety heads have positioning pins to ensure the correct installation of the disc. When pressure rises too high for the valves to relieve, the disc bursts instead of the internal piping or vessel components. This brings added safety for personnel and equipment. Another type of rupture disc is called a rebuckling disc, and they come in several forms. One form of rebuckling disc has the disc itself and a frame that holds a knife edge on the downstream side. When the disc reverses due to system pressure, the knife blades cut through the metal, the disc bursts. Other versions of the rebuckling disc do not have a knife edge. Instead, the disc is scored with a pattern, such as an X or a circle. Still another version is the Jaws type buckling disc. In every case, the dome of the buckling disc is always installed on the system side, and it rebuckles toward the downstream side. Rupture discs are designed to be the last resort pressure relief point in a system. The disc is set at a pressure higher than the safety valve, but less than 1.5 times the rated working pressure of the vessel. Simplicity is the main advantage of rupture discs. They are lightweight and have no moving parts. Also, rupture discs act faster than safety relief valves. Now, the main disadvantage of rupture discs is that they can't reset themselves when the pressure returns to normal. They must be replaced. Now that means shutting down the entire system during replacement. Also, there's no way to test a ruptured disc, because any test would be destructive to the disc. It's very important that the correct disc be installed properly. If the disc ruptures at too low a pressure, it may have to be replaced soon if necessary. If it ruptures at too high a pressure, protection for the system is lost and serious damage can occur. Proper procedures for replacing rupture discs are as important as proper selection of the discs. The disc should be installed, or at least vented, away from work areas or places where people pass by regularly. The environment must also be protected from the sudden release of high-pressure gas or liquid. Be sure a vent line is provided to carry discharge away from fired or high-temperature equipment. Even though the design is simple, great care must be taken to install the rupture disc correctly. Most safety heads have arrows indicating for direction. A reverse buckling disc has 3 pins to guide it, so the proper side is always facing downstream. Some safety heads have a hook called a J-bolt to assure proper installation. Follow the installation instructions carefully. It's possible that a disc installed improperly could be extremely hazardous, allowing system pressure to rise 8 to 10 times the fail-safe pressure limit. Rupture discs must also be protected from the outside environment. They are essentially bare metal surfaces, and exposure to the elements and buildup of foreign material will interfere with normal operation, so they should be installed with some kind of protection. And that brings us to the end of this section. Our topic in this section has been rupture discs. Get your student manual out now. Look over the material and answer questions. Now, we've discussed the difference in tension-loaded discs and rebuckling discs. We've seen how rupture discs are installed and how they protect systems from pressure. That also concludes this module of instruction. In this module, we've looked at various kinds of relief valves, safety valves, and rupture discs. We've seen how they're designed, how they operate, and how to install them. Safety is a top priority in the oil field. These pressure relief devices play a vital part in protecting personnel, protecting production equipment, and protecting the environment. It's an old saying, but it's true. Safety is no accident. The proper installation and maintenance of these pressure relief devices will keep safety first.